Hello, guys. Let's start the slideshow. Welcome to WEB204, session on speeding up your site's performance with a web cache. I am Steve Mueller, Solutions Architect for Amazon Web Services, based out of the New York market, where I cover a number of large enterprise customers in the media, financial, pharmaceutical industries. So today we're going to talk about web apps. How do you increase and improve performance of your web app? What go fast switches exist for you in those web apps? What options do you have in front of you? But before we get there, for those in the room who may not be as familiar with the basic web transaction, we should just baseline and say that a web app and its basic web transaction is really, at this point, a well-established design pattern involving load balancers in front of web servers and app servers, and those app servers and web servers will front-end, back-end services. That back-end service may be a database. That database may be relational database service, or RDS from AWS, or something that you run on EC2. It may be a back-end API call, or a back-end legacy system. But at this point, the basic web transaction is well-defined. But it does leave some performance questions for us, namely, does your application perform as well as it should? Corollary question to that is, are you characterizing your application's performance? Do you know what you should expect out of your application in terms of its performance? Second big question is, are you causing unnecessary strain on your back-end system? If you're hitting it every time for dynamic content that doesn't change, or even more specifically, static content that doesn't change, why are you doing that? You might be paying too much, and AWS offers elastic features to actually reduce the size of those instances and offset them with some type of performance cache. Finally, can you improve the experience for your customers? There's an old saying that if you don't hear your customers complain, then your website must be performing just fine. But the reality is, customers on your websites may actually be experiencing performance problems and you don't know it. So how do you address performance? How do you transform your jog into a sprint? The use of a web cache will be the focus of today's session. There are three major go-fast switches, as I like to call them, however, in a web application. So let's take a look at what those are. First is the in-memory object cache. As you will find out, this is traditional memcached or Redis. We also look at web caches themselves, front-end web accelerators. And finally, the concept of content distribution networks for global edge content delivery. Which go-fast switch should you choose? I argue there's not necessarily one that's right. Let the use case drive which go-fast switch you will choose for your web app. So to set the landscape for this conversation around web cache, and in particular Varnish, we have to understand what that landscape looks like, as I said earlier. First, in any web application today, you have the option to implement an in-memory object cache. This is usually a key value store. Why are key values so important in HTTP? Well, the HTTP session state itself is a key value pair. I have a key that equals a value. Therefore, I would like to store it in memory as a key value pair. Object caches are great for handling small chunks of small data. That data could be arbitrary in size in terms of volume. Some object caches in memory get up to gigabytes in size. That is an optimization. The key takeaway on an object cache is really focusing on the result of a database or an API call. And as I said earlier, memcached and Redis are great examples of in-memory caches. From this diagram, you can see that the in-memory object cache sits as a layer between your EC2 instances and your back-end systems. In this example, I'm using databases, and I've selected a few. I don't have Postgres up here, but we'll assume Postgres and any other relational database for that matter would work. The goal of the in-memory object cache is to reduce your database wait time. I talk about back-end for the simplicity of this conversation, we'll just assume a database. And by not only reducing the wait time, you're also pulling away unnecessary resource consumption. There is a time when your database may be running hot on CPU, cycles in executing stored procedures you don't need to execute every time. Other times you might be running hot in memory as you have temp table space for joins. The question is, why would you do those large-scale joins if you don't have to? So that is the goal of the in-memory object cache. The second go-fast switch that really exists in the web app tier market today is what we call the web cache. This is also referred to as a content cache, web accelerator, reverse proxy in some scenarios, or an application delivery controller. It takes on many different names, but in the end, it is the same thing. Its purpose is to cache front-end response objects and not those from an individual API or database call, such as the in-memory object cache. The big takeaway here is when you hear web cache or web accelerator, you should think this is going to handle my static and dynamic HTTP content. That's a little different than if we interact with a database. The database is all about strings and lookups and objects, and I don't want to go back here and do this again because if I can afford to take 85% of the workload off my database, I should. This is actually more about how do I cache HTTP responses? Maybe it's an API call, REST call. Maybe it's just a standard dynamic HTML page. How do I reduce the load on those servers? That is the goal of today's session, and understanding web caches and Varnish in particular. As an example, in today's session, we talk about Varnish, but the market also offers a number of other web caches, such as Squid, Apache Mod Cache, Nginx. You may be using these today. If so, we hope to bring something new to you for the Varnish discussion. So where does the web cache sit? It sits in front of the web and application tiers, usually between the load balancers. Now, if you've got this implementation or have done this design in the past, you may realize that immediately we've already posted the best practice. We'll explain later why this is a best practice. We could have simply put the web caches in front of the web tiers as well and reduced the need for the load balancer there. All right. But in the end, you see that the most important takeaway is not only is it caching the results of its static and dynamic HTTP content, but what is the website now? It is no longer your EC2 instances. It is a set of EC2 instances running a web cache such as Varnish from a front-end VIP or load balancer. Now, before we dive into web caches, again, the goal of today's 204 section, we should understand that content distribution networks exist as well. And I will call it out up front that there is some early concern if you're new to the web cache and content distribution game that, boy, they seem awfully familiar. Well, that's right. But there is a separation of purpose here. A content distribution network is really identified by its ability to distribute content all around the world from locations in geographies and do things like geofencing and restriction. Today, Amazon offers a content distribution network, or a CDN, as the industry calls it, known as AWS CloudFront. It is also referred to as edge caching, border caching, edge caching. And like web caching, it too handles static and dynamic results. The difference between a web cache and a CDN is that the web cache lives behind your proverbial firewall, local. The CDN lives global, external to your application, external to your VPCs. Here we see an example of that. Amazon Web Services today offers 52 geographical locations for CloudFront, and it uses one or more sources behind the scenes, what we call back-end origins. So we've highlighted just by the stars some areas that we're actually featured in. You can find all of our CDN locations on our website under the Global Infrastructure section. So let's take a deeper dive into web caching. The content starts at what's known as the origin. If you look at what we've got in this slide, as opposed to what we looked at in the last slide, the origin is actually defined as a subset of what would appear to be the overall application delivery engine. That origin features a load balancer, a set of one or more EC2 instances, and if you're following best practices, auto-scaled across multiple availability zones, with your back-end services. This origin produces content as a back-end service to one or more nodes running on EC2, known as a web cache. The web cache consumes the origins. So in this example, we see that we've got a front-end load balancer. That front-end load balancer is actually what's mapped to your public endpoint space, as in this example, an external ELB. This is the load balancer that your customers will hit. You could be surfacing API calls for REST. You could be surfacing web content. Again, the takeaway in a web cache isn't HTML, it's HTTP. So what you're actually caching is a result set. As long as it's HTTP, you can provide that to your end user. So, for example, let's say we've got an Elastic load balancer, and that has Route 53 DNS, public DNS, because we've just announced private DNS a few weeks ago. But we publicly create a DNS record and map it back to the ELB. That is the URL right here that your customers will hit. Now, assuming that there is a match for a result that's already been cached in the web cache or web accelerator layer, there's no need to actually traverse back to the origin. This is all local. As you can see by the lock, we indicate that this happens in your VPC. We are behind your proverbial firewall, quote unquote. And that's an important distinction between a web cache and a content distribution network. This also helps buffer against the origin. Why is that important? The key to a web cache's success is how well it can protect your origin. The origin being the source of your content delivery within the local VPC. It makes your websites work smarter and more efficiently, not harder. As I like to say, your servers are not in a gym. They don't need to be working out all the time. And this is important because, as I show you in the last bullet, a small number of web cache instances, such as Varnish, will actually help you reduce in the long run the overall cost of your web application. For example, assume that we're running at a C3-8XL. That's the largest CPU compute instance we have, 32 vCPUs, 60 gigs of memory. By putting just a small set of maybe M3 large instances, 2 vCPU, 8 gigs of RAM in front of it to offload and handle the cache, you may be able to reduce yourself down to a C3-4XL or even a C3XL, a savings that can be significant in the long run. So the elasticity that you've been hearing about all this week at reInvent from Amazon Web Services comes into play when you look at how can I actually get these instance types down in size. Put a small layer of cache in front of them for the HTTP response using a product like Varnish, and this can overall reduce the cost of your monthly bill. In addition, origins, no matter how well designed, are at risk for failure. Again, the best practice design is to go multi-availability zone or multi-AZ, but why not place a web cache layer that spans multiple availability zones as well to mitigate any risk here? Buffer the origin. If you hit the cache, what we call hit the cache or a successful hit against this web cache, there's no need to worry about what the back end does. This concept, by the way, translates not only from web cache but also to content distribution networks. The idea being, for example, in CloudFront, if S3 were to ever go down and you've got it cached in CloudFront, you never have to worry about the S3 failure. You decouple the source origin from the delivery mechanism, and that is exactly what we're doing here. Finally, one of the bigger pain points for certain application stacks. I have a customer where that customer says Drupal is tough because of the policies and decisions in its rendering capabilities. They were forced to look at a web cache to assist in getting better response times for their customers. So some application stacks don't render content as well because there's a lot going on in the decision-making tree of the rendering process. This is how you protect your origin and ultimately deliver a better experience for your customer. So I've mentioned Varnish a few times. Let's step back and take a look at what Varnish is. Some of you may be using Varnish, some of you may be using Apache. We'll use Varnish in this session as an example, as I've already mentioned. Varnish is an open source web accelerator. It is the web cache, an example of the web cache that we've been talking about. It was developed in 2006 by a gentleman at a Norwegian tabloid newspaper. He ran in the online division of it. About 8 years ago, he said, we can do this better. So he developed Varnish. He took Varnish, hired a company called Linode. They spun into their own company, what you have today in the Varnish open source world. There's also a commercial implementation of Varnish that will provide support and management for you. Varnish's history, 1.0 was in 2006, 2.0 was in 2008, 3.0 was in 2011, and finally we reached version 4.0 in 2014. And if you follow the Varnish track, there were big milestones at version 3 when they offered gzip compression and decompression. Just some historical notes about Varnish. Varnish, actually, going back to the original architecture that we've pitched involving your origin, which again is your load balancer and your EC2 instances with your backend, Varnish, it becomes the web cache. It is that web cache layer. And it runs on EC2 instances. It can run on Ubuntu. It can run on Amazon Linux. It's very straightforward to install. We'll actually show you how easy it is to install in a few slides. And again, it all runs inside of your VPC. And the idea is that you span multiple availability zones with each node and load balance accordingly with your external load balancer. Now, just a few items here to highlight as well. This load balancer in the front, of course, is the external ELB, as we've mentioned. And of course, you've got your Varnish nodes. Those Varnish nodes actually can live in the private subnets. There's no need to surface or expose them in public because the load balancer, the external load balancer, will do that for you. So tuck as much of this away as possible if you're putting services in a public subnet that don't need to have a public IP and be directly accessible from the internet. Revisit that design and tuck them into the private subnet. Diving a little more specifically, Varnish will actually turn to an internal load balancer. This internal load balancer will listen to one front end inside the private subnet and also broker the exchange back to one or more instances behind it, also in private subnets. Not one element here sits in the public subnet. There's no need for that. Don't expose yourself to extraordinary risk. While we're here, we might as well discuss that. And then finally, your database servers. From an architecture perspective, there really are two different patterns you can use Varnish with. You can actually load balance. You can handle and manage the load balancing in front of your EC2 instances yourself. Or you can actually provide a back end to Varnish, which is nothing more than a load balancer. The slides we've shown to date have been using the internal load balancer, which is option 2. Earlier I said this was a best practice. The reason for it being a best practice is what's the challenge if your web cache is sitting in front of EC2 instances that are auto-scaling? So if you have a web cache in front of a set of EC2 instances that auto-scale based on some triggered condition, how does the cache know who's in or who's out? I got spun up within the last 30 seconds. I actually had 3 instances spin up. Well, the web cache is saying, hey, listen, you know what? I'll handle the load balancer. I'll be the load balancer. Forget it. We don't need to use ELB. I'll be the load balancer. Well, you have to have some smarts then if you're going to be the load balancer. And the problem is, and why this is actually a best practice to use the load balancer, and why this one, while functionally feasible, will become operationally difficult, is because you're left having to do all of the management of the auto-scaling layer yourself. Let me give you an example. This is the real talk. You have to actually write a cron job. That cron job has to run every minute. Every minute you have to query our APIs. You have to say, hey, what's the current status of auto-scaling? How many instances are in here? I have 65. Oh, I had 60 last time. And then you have to maintain state on that. And then you have to take the current state of what you've got and resolve it against the previous state and go back to Varnish and say, oh, let's inject a new configuration in here, please. We're actually 5 more servers than we thought we were. So while it's not a bad design, I wouldn't necessarily recommend it to my customers in New York. Why? Because you'll spend unnecessary compute cycles calculating auto-scaling events. Aren't we trying to get away from unnecessary compute cycles? By simply going to a load balancer, you delegate the responsibility to the services that are meant to do just that. So while it might feel strange to actually say, I've got a layer of 1 or more EC2 instances that are caching HTTP responses and using a load balancer as a back-end origin source, doesn't matter. It looks like a VIP. It looks like a front-end URL to you. Let the load balancer do the work for you. And also, again, why? Because ELB plays really well with auto-scaling natively. Handles it all. So there's no need from where we stand at Amazon Web Services, we would recommend to you and our customers outside of this room, web caches, be it Varnish or anything else, look at using an ELB as your backend. Just a few points about Varnish itself. The process is an HTTP daemon that runs on your system, known as Varnish D. You'll see in a few slides that it actually runs off a configuration file. Varnish has got a domain-specific language that lives in this configuration file. The web content itself is stored in memory, and this does create a more advanced condition that you have to look at once you get familiar with Varnish about how long do I want things to live in memory and what if it went down and how do I repopulate that cache? These are all topics that are a little more advanced than here today, but nonetheless, I'll actually show you a few slides where we talk about that. While the web content is stored in memory, it is paging to disk. And one of the things that the Varnish community likes is that it doesn't do the paging to disk. It lets the operating system do that. So the value there, and it's not necessarily apparent at first glance, is that if the operating system is trying to page and a process running as a daemon is trying to page, there's a level of contention. And the goal here is to reduce CPU and memory contention. So Varnish made a strategic decision in their design to actually allow the OS to page. I apologize, I went one back. This does reduce the contention risk. Client requests that come in to the caching layer are actually handled by what's known as worker threads. And each worker thread will handle an individual client request. And you can configure the number of worker threads that you have in your process, and this becomes a more advanced tuning parameter for Varnish. How many threads do I want running in a process? That's independent of Amazon Web Services or any technology. That is a function of the operating system and general process architecture. If a client request comes in and all of the worker threads are filled, you will go into an overflow queue. You will want to look at the statistical data coming out of Varnish as to the utilization of your threads and how many you can handle concurrently. Why is that important? It's important because the whole goal of Varnish in the end is really to give you fast delivery, and we see it in content delivery systems in front of systems like WordPress, Drupal, other CMS systems. And so you're going to see concurrency at scale. So one thing you want to think about if you're looking to use Varnish or a web cache in general, what's the concurrency factor? How many concurrent how many concurrent requests do I expect to process and service? As we said earlier, it can front-end the EC2 instances itself as a load balancer. or it can front end the load balancer itself. The takeaway here should be flat out, please use the load balancer. Auto scaling is a difficult event to capture. No need to burn cron job cycles on it. So at a high level, some features of Varnish that the community actually prides itself on. It is designed for content-heavy websites. These websites are also, don't assume it should just be static. One of the features of Varnish is something known as an edge side include or an ESI. The ESI, or edge side include for short, it's akin to saying, I have a page that 95% of the content is static. 5% is actually going to change. For example, if I pull up the Amazon Web Services console, the dashboard is pretty static. But two things change. My username, actually that doesn't even change at all. But the region, it could change. Those are personalized elements. And a lot of caching systems and people who implement caches think there is a small part of personalization on this page, therefore I cannot cache any part of it. Yeah, it's dynamic. The region you select is dynamic and based on the context you're in. But edge side includes in the web cache actually allow for you to carve out and select which pieces you want to cache and which pieces you want to send along to the origin for rendering. So imagine, you actually are able to carve out a personalized area of a website using some directives and scriptlets and configuration and say, you're not going to cache this. That part of Amazon Web Services console that everybody knows, the dashboard that just changed yesterday, I think, when we all looked at it and said, oh, where's CloudFormation? Where's VPC? All of that is static. You can mark that as static in the ESI. As of Varnish 3.0, gzip compression and decompression was released. This is a big feature. Prior to 3.0, you actually had to go to an external process system, third party. 3.0 made that irrelevant, and it is now today featured for reducing the bandwidth. Why is that important, by the way? Because outbound data is the data you get charged for in AWS, right? You don't get charged for inbound, you get charged for outbound. So you're not only looking to cache your web content, your HTTP content, you're looking to also reduce the bandwidth and the requirements for data on the outbound. It does, like we said, utilize persistent storage. By having a disk in the back end, you don't have to evict based on least recently used, LRU. So traditional caching systems will use LRU algorithms to say, I only have so much size and memory to hold these objects. You haven't been touched in a long time, you're out. That's the LRU pattern. But by paging to disk and becoming persistent storage and being able to be retrieved from storage when it needs to get called back into memory, you don't lose your objects due to LRU eviction. Oh, I actually would be a bit remiss if I didn't call out the biggest one. It's HTTP only. Varnish is HTTP only. There are some caches that will handle FTP, SMTP, and other protocols. This one is HTTP only. And there's a reason they did this. Speed. Varnish is very fast as a result of focusing and optimizing on just the HTTP protocol. I know we all like to see configuration files up on our slides, so I thought I would share something with you. Varnish has a configuration language known as the VCL. This is the Varnish configuration language, and it allows you to programmatically define and handle each request and implement document caching policies for an incoming HTTP request. So for example, this is actually an overridden method in VCL that says, let's purge. But says, oh wait, I'm only going to accept purge requests from the local host or anybody in the 10.12/24 network. And in Varnish, in the VCL in particular, the method known as VCL receive, RECV, you see it reads pretty much like, I'd say, well, you could say Python, you could say Perl. If the request method equals purge, and if the client IP is not equal to that of the ACL purge object, meaning you weren't allowed to purge, then let's return a 405 error and say you're not allowed. Otherwise, go ahead and let the purge call continue. The point is, with VCL, you write this configuration in a way that overrides the methods that VCL calls. VCL is, or Varnish in particular, is a hook-driven system. These are hooks that you're overriding. This is how you control and configure your web cache. You tell it what to do. All right? And in doing so, in taking this language, it is translated to C for you. It is compiled down to a shared object and is loaded directly into the web accelerator. Technically, it stands on its own next to it on the side. But this has an important value, and that is you don't need to restart the accelerator. It's configuration management injection, if you will. Injection of configuration management, or rather injection of configuration. So how do we configure Varnish? Varnish 6801 on the port. There's an administrator port as well. There are command line management tools that allow you to modify the parameters of Varnish. Again, compiling, loading, and activating your handlers without restarting the accelerator. This is important, right? Restarting an accelerator would mean an outage. And that would mean I'd have to have more Varnish instances or auto-scaling policies to take over where these guys went down. So restarting Varnish would be a bad thing in terms of performance. And of course, you can control things like the number of min-max worker threads. You can analyze the throughput, concurrency. Timeouts are particularly important. They're out of scope, actually, for this session. But when you get familiar with Varnish and you start to dive in, you start to really focus on time to live values. You start to focus on where's my expiration? Where's my cache control? How do I evict? When do I actually want to invalidate my cache? More advanced topics, but configuring Varnish will allow you to do just that. So why Varnish? Again, earlier we said that there is support for well-known CMS and e-commerce stacks. Magento and WordPress are two that come to mind. In fact, we have another session with my colleague Sean Pierce out of the UK where he will focus on Magento and Varnish. I believe that is tomorrow at 9 a.m., by the way. I believe. Pages on the site that are dynamic but don't change often. Search results, actually. This is kind of falls, if you talk to certain individuals, they feel that search results are similar to e-commerce stacks. Right? If you go to Amazon.com and you search for a book, it will probably always return the same book based on the same ISBN. Odds are the ISBN didn't change, so it's the same book. So search results can be equated to similarly commerce tools, and they don't change much. So why not? Why would we do the search over and over again when we can just draw it back from the cache? Again, a sleeping instance is a good instance because it means you can turn it down in size and save yourself money. C3s are more expensive than M3s. Built for speed. It has one job, fast. So some tips and tricks for Varnish. These do get you into the more advanced areas, but I felt like let's open this up a bit and dive a little deeper, even if it's a 204 session. The concept of the hit ratio for a cache is if I call for an object, is it in the cache? And what's the hit ratio? 95% successful, meaning 5% of the time it wasn't in the cache. I had to actually retrieve it from the origin. The higher the hit ratio, the better your cache is doing. 100% means you're absolutely not touching the servers at all. And who knows, maybe you can even reduce the number of instances behind it. Now, there's a trade-off. When you increase the hit rate, when your hit ratio increases by keeping time to lives high. Now, the time to lives, let's just stop there for a minute. If you raise the time to live, it means it's going to exist in the cache longer. So if it's in the cache longer, odds are you're going to get more hits. But the challenge is on the flip side, a longer TTL means you may be at risk for going stale behind you. Oh, I'm getting awesome hit ratios. Oh, well, that data was 5 hours old. It's now updated. So these are things that you need to look at as you dive deeper into Varnish. TTL is probably one of the most advanced areas of configuring it. And how do you stage that TTL against all the other elements you're caching? Okay? There's this notion, I have a customer who calls it nuking. That's his colloquy, I guess is the word. We call it cache eviction or invalidation, really. Best practice, don't purge your cache and varnish. Don't call for purge. Even though you saw my example, that was an example for the VCL. Really, don't purge your cache and varnish. Let your origins do it via HTTP control headers. So when you deal with caches, and HTTP in particular, you have to refresh your memory if you're not current on it, or if you're like me and you tend to forget because you get older every year. You got to think that there's no cache option for HTTP. There's an expires for HTTP. HTTP as a protocol definition has a number of parameters that control the lifespan, or TTL, or the expiration date of an object. Cookies also have an impact on Varnish too, by the way, so take a look at that. So if the origins control the life cycle of how long that data lives, you can push it all downstream, and I have a diagram that shows just that. So don't purge your cache and Varnish. It's a very expensive operation. One thing to note about Varnish too, I didn't talk about this. Caches can go very large. These are in-memory processes. We've seen caches get up above 1 gig or more. Right? I think the default configuration for Varnish may be 256 megs, but it's not uncommon to see caches go 2, 3, 4 gigs out in size. That's the job of a cache, right? Large memory. And so when you purge a cache in Varnish, you got to think, how much am I purging? Or worse yet, how long is it going to take to load back in? I have one customer who, on a more advanced area, they do purges, but they don't necessarily always know when they're purging. So it's a non-deterministic state. They say, oh, wow, we might be stale. Or do we have the current data set? That's called non-deterministic. Deterministic in cache world is, I have this, and I know it is exactly the updated copy of the data in the back end. That is a deterministic state for cache systems. Non-deterministic says, I think I might have the right one. I don't know. And so when you get into this area, it's very dangerous. Because dangerous in terms of you could deliver something that's out of date, right? So it's a bad customer experience. That would be bad for us at Amazon, right? What if we told you on the .com side, we have 22 instances of this, and we were caching that, right? But it wasn't up to date. And the reality was we didn't have any left. So bad customer experience. So when you have to resolve a non-deterministic Varnish cache, it usually ends up in my customer's case of you take it down. And if you're at 2 or 4 gigs in size, that's not necessarily fast to load up, right? So keep that in mind. Probably the biggest one that my colleagues in particular will really drive home with our customers is make Varnish a part of your design. Don't bolt it on after the fact. This will increase your efficiency and your use of Varnish. There's this afterthought of, I called it the go fast switch. And I do that because I've worked in companies in the past where the idea was we built this, we developed it, and then, oops, it didn't perform. Somebody go hit the go fast switch, right? The panacea of it all, the solution to it. If you design for a caching system up front, you will get better utilization of this. This is just like security. They go hand in hand. They shop at the same aisle in the grocery store. Right? Increase your cache efficiency by designing for it. Don't use an endpoint into your Apache servers or your Nginx servers and think, I'm just going to put a cache in front of it. And coming back to ESI, I mentioned this earlier, but I'm going to drive it home again in a different way. Edge side includes are your friend. And on a more advanced area, focus on how many of those you're using. If you have configuration ESIs that say, I'm going to pull out 42 different pieces of this page because they're personalized, as you start to study Varnish on the more advanced level, you'll realize that's 42 calls back to the back end, right? Well, maybe a few was good, but if I'm making 42 calls to the back end, I probably really have a very dynamic page. So study how much of your content is truly dynamic. How much you really can cache versus how much really needs to go to the back end. You might actually hurt yourself by saying, I'm going to try to cache this and use ESIs. But at the same time, don't throw the baby out with the bathwater. Just because there's personalized content or in Varnish terms, there's a cookie in your return response, which indicates personalized results, okay? Session-based results, personalized results. Don't throw it out. Use ESIs, use them well, and study how many times you're going to go back and forth to the back end. So something that is a nuance, but certainly, as my colleagues and customers will tell you, your best friend. My favorite slide. How do I start? It's actually, I'm a big CloudFormation fan, but this is actually my favorite slide because it's 2 lines. CloudFormation ends up being about 12 lines. AWS EC2 run instances. Spin yourself up an EC2 instance. If you're on the Amazon Linux platform, you'll do a sudo yum install Varnish. If you read the Linux, you'll do apartment get. That's the Debian package format for Ubuntu. So very straightforward. Get it from yum. Get it from your appropriate package installer. Install Varnish. So as we wrap up with just under 4 minutes to go, putting it all together, we started out by saying the web app and its performance are directly impacted by 3 areas that you can control in your design. And I said, wow, we've got Memcached and we've got Redis, we've got this thing called CloudFront from Amazon Web Services, we've got Web Cache. Where does it all come together? And if you remember earlier, I said, which go fast switch do I turn on? The reality is you can have them all 3 on as a best practice. Taking a review of it, why wouldn't we put an in-memory object cache like Memcached or Redis between the middle tier and the database? Why wouldn't we use a web cache in front of a load balancer and treat this whole entity as the application origin? In fact, if you notice, the in-memory object cache of Memcached or Redis in this example are actually part of the origin. There's a cache within the origin. And now I've got a web cache. And then finally, you can roll this all up to your content distribution network, right? CloudFront. Again, the idea is, make no mistake, CloudFront has to go back to an origin. It has to fetch results. If the time to live is expired or if there's a missed hit, it will go back to that origin. And we're talking about mostly dynamic content here. We're not talking about S3, right? S3 applies the same way, but focusing on CloudFront. So you end up in the more advanced areas of Varnish, and this is what I want to leave you with, is yes, you can put it all together by using the 3 types of caches that we've talked about. And in the end, you get a very local database services cache. You get a HTTP accelerator or web cache like Varnish. And you get global distribution across, in Amazon Web Services, 52 locations worldwide. And the goal in the end is to not only help you give a faster response to your customers, but also to allow you to reduce the instance size and the number of instances you have running. And this translates to a lower monthly cost in addition to better customer experience. So with that in mind, that will conclude our session for WEB204. Please give your feedback on this session. And if you could complete the session evaluations, you can earn valuable reInvent swag. Thanks, guys.